In the previous video you have learned how I/O redirection works on Linux. In this video we'll explore some examples. So first let's have a look at the pipe. Pipes are useful for commands that produce a lot of output, like ps aux. As you can see, a lot of output is generated. Too much to read it while it passes by. So if you want an opportunity to read it page by page, you need to pipe the output through less. Less is a pager that allows you to see every single page of output, and you just need to hit the space bar to proceed to the next page and Q to quit from that. Pipes can be useful in other situations as well. Basically, by using pipes you can combine generic commands to create your own very specific command. Let's have a look again at ps aux, which produces a lot of output. As you can see, the output is formatted in different columns. In the second column of this command you can see the process ID. Now imagine that you just want to do something with process IDs. What you could do is pipe the output of ps aux to the awk command. Awk is a filtering utility. We will explore it in more depth in lesson 4 of this course. Oops. Now let's pipe it through awk and tell awk to filter out the second column, which we do by telling awk print $2. As you can see, at this point we just have the second column, which is the process IDs. Now if for some reason you want to sort the second column, you just pipe it again through the sort utility. Now isn't this a weird way of sorting the output? That is because sort doesn't know that it has to sort by number. If you want to sort by number, make that sort -n, and you can see that perfectly all process IDs are sorted by numbers. You see, that's how pipes turn simple commands into complex ones. Now let's shift over to I/O redirection. We've talked about I/O redirection already, and I have explained the std in, the std out, and the std EWR file descriptors. That's for standard input, standard output and standard error. Now let's have a look at an example where we are working with that. When as an ordinary user I type a command like find /name *.rpm, RPM, I get a lot of permission denied errors. That's because normal users cannot search through all directories. If I just don't want to see all those errors, I can send them somewhere else, like to the dev null device. To do that, I need to tell my command that I want to redirect file descriptor standard output, and I do that by adding to greater than and tell it where to send the output, which in this case is dev null, with the result that I don't see the output anymore. I could also send it elsewhere, like to a file, for example. So if I want to send my errors not to the standard output but to a specific file with the benefit that I will be able to read them later, I tell it to send it to my home directory, this home directory. In my home directory create a file with a name like find.err. So we still see the normal output on the screen, but all errors have been sent to find.err in my home directory. So let's do cd to go to my home directory. Let's do an ls -l on find.err, and we can see that we have a relatively big file that has been created. So if I want to see the contents of this file, I can just type get find.err, and you can see all the permission denied errors are there. This is an easy way of saving errors that have been generated while doing whatever you want to do on your server, and analyze those errors at a later stage. So that is how you can redirect standard error. You can also redirect normal output to another file. Instead of doing 2 greater than ERR, well, we just use the greater than sign, which is greater than, let's call it rpm.results.txt, and create it in my home directory as well. As you can see, now you can see all the errors appearing on the screen and nothing of the normal output. Now, if you wanted to redirect both of them, that's possible as well. Let's just redirect the errors to the null device and the normal output to a text file that is created in my home directory. And now we can see that the command doesn't generate any output whatsoever, it just creates 2 files, and these files I can read them quietly. Now in the last command what you have seen is that I have redirected once more to the rpm-results.txt file. Because I'm using a single redirector, this will overwrite all the contents that's already existing in the file. It will just erase the file and create a new one. In some cases it might be useful to not overwrite but to append the result of the command to the file. If you want to do that, just make that a double redirector. So greater than RPM results, and a 2 greater than is what the command would look like if you want to append to the file. By the way, it doesn't make any sense to do greater than to def null, because def null is def null. That's nothingness, and yeah, it just disappears. So why would you want to append to that? Now you can also do input redirection. Let me do Ctrl U to wipe my command line and Ctrl L to give you a clear screen, and let's have a look at some input redirection. Now, input redirection is a way to feed the contents of a file to a command. Let's do some example in which I want to go to the root of this machine and type ls to show a list of files, and let's send the output of this command to home directory /file_list.txt. Now the output has been saved to file_list.txt, and if I wanted to sort the contents of that file, I can use the input redirector like this. Did you notice, by the way, that bash has command line completion? So in here I have typed home directory /file_l. If I just hit the tab key now, it automatically completes the name of the file, as long as it's unique. You could see that it stopped at file_list, and that is because if I hit the tab key again, I can see there are 2 files with a name like file_list. We have file_list and file_list.txt, and it's the .txt file that I want to use here. As you can see, file_list.txt has been used as the input for the sort command, and the output is displayed on my screen. Now if I really wanted to do something cool, I use an output redirector as well. So first an input redirector to read the file, and then the output redirector to write the output to file_list_sorted.txt, for example. Oops! And that's a permission denied. Now do you have any idea why I'm getting a permission denied? No? Well, that is because I'm an ordinary user. The ID command shows me that. As does the $, by the way, on the prompt of the ordinary user. And my current directory, let's do pwd, my current directory is the root directory. And in the root directory, ordinary users don't have any rights to write whatever they want to write. So let's correct this, and let's add ~/file_list whatever to create the file in my home directory. Now I'm good, and that's all I wanted to share with you about redirection.